Sir, you can start.
Yeah. Hello and good morning. So we go into the medulla oblongata now. That is the lowest point of the central nervous system other than the spinal cord, right? So from spinal cord we are graduating into the medulla oblongata through the foramen magnum. So we just go and see the competencies for today. Oh, everything's upside down. Upside down and front to back. It looks better. Flip. Yeah. That's better. Yeah. So we go to the first slide, which tells us the competencies. Sorry? The competency 58.1. I'm not audible? Eh? The mouth, yeah.
So it's flipped for us.
How is it now? Can you hear me now?
Sir, now it was flipped, sir. So now it's upside down.
Now it's upside down. Oh, no.
Yeah. Yeah, now it's upside down.
Wait, just a minute.
Yeah, now it's correct.
Now it's okay, sir.
It's okay. Yeah, it's okay.
Yeah. Yes, sir.
Yes, sir.
Now okay, sir.
Now okay. Shall we start? But on my screen it's other way around. Eh?
You can see here, sir.
Yeah.
You don't
Okay.
see that.
I don't look there. Fine. Now competency. Number one is external features of the medulla. Then transverse section of the medulla at the level of the pyramidal decussation, the sensory decussation, and the inferior olivary nucleus. Then competency 3 is the cranial nerve nuclei in the medulla oblongata with their functional groups. I hope you remember your functional columns. Yeah. Then the anatomical basis and effects of medial and lateral medullary syndrome, which is the condition that affects the medulla, that is mainly a vascular problem. Now, this is the section of what? The spinal cord. Now, why do I show the spinal cord when you are in the medulla? So, that is just to show you what happens to the gray matter. Hey, somebody mute your mic.
അയ്യോ അമ്മ ഒരു കുഴപ്പം പറ്റി
Amma, please mute your mic. Okay, that's fine. So what you see here is that there's an H-shaped central gray matter which surrounds the central canal. This is your central canal, and this is the H-shaped gray matter that you see here. And this is surrounded by the white matter, right? So what you have in the gray matter? The gray matter, you have got neurons, neuroglia, and the blood vessels. And the white matter, you got nerve fibers. No nerve cells. Please don't say neurons in the white matter. Nerve fibers, glial cells, and blood vessels. So that is what you find in the white matter. Even though I've given color, green color, blue color, yellow, and all in the white matter, Remember, that is the white matter, and this portion in the middle is your gray matter, right? And the central canal that is lined by ependymon. Now, we have to see in this particular diagram of the spinal cord, you can see that this got a posterior part here and an anterior part. So this anterior part is mainly concerned with motor activity. They contain alpha and gamma efferents or motor neurons. And here you have got the sensory part, which will have the first order neuron in your dorsal root ganglion. Do you remember the dorsal root ganglion? There's somewhere here. Has got a peripheral process and a central process. So the central process comes through the dorsal root and then comes here. And there, first you encounter one little tract called as the Lisso's tract. And deep to that you have the substantia gelatinosa, the nucleus proprius, and the nucleus dorsalis or the Clark's column. But mind you, the Clark's column does not extend throughout the spinal cord, but it is confined to some places in the middle. Oh yeah. So you may not find the Clark's column throughout the spinal cord. So that is the general arrangement of the gray matter. Now we have got the white matter. What shall we put in the white matter? We need tracks to take whatever input has come from here to the higher centers, right? So what we do is we need ascending tracks which ascend from the spinal cord and go to the central nervous system, or at least some places in the brainstem. So there is the ascending tracks, and from there you have to have the input that comes from the CNS down, from the brain to the spinal cord. So that is the descending tracks. So here what you see is, it always starts with spino and then goes to another place. So spinocerebellar tract that goes up there. So you got a posterior spinocerebellar tract and a lateral spinocerebellar tract. Similarly, you have a spinothalamic tract which goes in the lateral funiculus. So this is the lateral spinothalamic tract, and here which goes to the anterior funiculus is the anterior spinothalamic tract. And in between you have smaller tracts which are the spino-olivary tract, and sorry, this is not spinorectal, it is a spinotectal tract which goes to the superior colliculus in the midbrain. So that is your main ascending fibers. Then fibers that come down from the cortex is the lateral corticospinal tract. Then you have a rubrospinal tract, then a vestibulospinal tract, and a tectospinal tract. The existence of olivospinal tract is a big question mark. We don't know. And this again is the anterior corticospinal tract. Now, what's the difference between the anterior corticospinal tract and the lateral corticospinal tract? The lateral corticospinal tract comes from through the pyramid. It is a cross tract, whereas the anterior corticospinal tract is an uncrossed tract which crosses at the segmental level. So that is the basic principle of your CNS, the arrangement. Now, how is it concerned with the medulla? So now we have to adapt it to the medulla. Why should we talk about the spinal cord when you're talking about the medulla? When these tracts and the gray matter reaches the medulla, what happens is, here you have got only segmental nerves that come from each segment. Anterior segment, it goes like that to the motor to the segment, and here also it comes from the segment. But when it goes up to the CNS, what happens is, this innervation is mediated by the cranial nerves. Now the cranial nerves do not have a segmental disposition, but they come out through different places in the skull, and then they innervate different parts of the upper part. There's a head and neck. So that is the difference between the medulla and the spinal cord. So we have to adapt to the medulla. While most of these white matter tracts, they ascend beyond the brainstem and the medulla, you find that there's something unique in the region of the medulla. This gray matter gets rearranged. So you might remember that on the upper side here you have the general somatic afferent, that is the sensations that come, general sensations of pain, touch, temperature, proprioception, and all that come through the posterior root. And here you have the efferents, that the general somatic efferent that goes out to supply the skeletal muscle. So these are the two basic nerves that get in and go out, and the nuclei. Whereas here in the intermediate lateral column, you have got visceral nerves. So here you find the afferents that come to the visceral. So you have got a general visceral afferent, and here you have a general visceral efferent. So general visceral afferent gets sensations from the viscera, and the general visceral efferent gives sensations to the viscera. That is, they innervate the viscera, namely the glands and the smooth muscle of the viscera. So that is the general visceral efferent. So that is the general area. Now, in addition to that, when you reach the medulla, what happens? Let's see. Yeah. So see, when you reach the medulla, you find that the upper part of the medulla, this just opens out. See, this lip and this lip, which should have been in the midline over here, this just opens out, and then you find that the inferior medullary velum will bridge this gap over here, right? And so, in addition to that, we find general somatic afferent, which was on the uppermost part here, that has been slightly displaced medially, and then this has been occupied by one column that is called as the special somatic afferent. Now, what is the special somatic afferent? Yeah? Okay, I can ask you directly. Then after this, you find that interposed here, you've got another one that's called as a special visceral afferent. What is special visceral afferent? Yeah? Taste. And special somatic afferent, something to do with your body, that is smell and hearing. I mean, hearing and the balance. That's a vestibulocochlear nerve. This occupies this region of the special somatic afferent. With special visceral effect, you have got smell and taste, right? And then you have a general visceral afferent that was already there in the spinal cord, so we just leave it like that. And then special visceral efferent is something that is crept in here. See, special visceral efferent. And this is what supplies the muscles that are derived from the branchial arches. So that is an extra one that is crept in here, right? And general somatic efferent, we already saw in the spinal cord there's a general somatic efferent. So it does not concern us. So that is what happens in the medulla. So now we have to find out which are the nerves which take out small parts from each of this, right? This need not go into especially one nerve. So something like your glossopharyngeal nerve or the facial nerve, they can have multiple nuclei that will send their processes or the nerves to these, their processes or the axons to these nerves. So also the vagus can also supply the branchial the musculature that are derived from the branchial arches. It can also supply the smooth muscle of the viscera. It can supply the glands of the head and neck and viscera. So they can have multiple functional columns that contribute to that particular nerve. So that's the difference between the medulla and the spinal cord. Yeah. Okay. So here, what we have just said, the special somatic afferent, vestibular and the cochlear nucleus represents the special somatic afferents. Then the nostril nucleus of the vagus is here, and then the hypoglossal nerve is here. Now, what is this hypoglossal nerve supply? Is it general somatic efferent or general visceral efferent? It's a general somatic efferent, because the general somatic efferent supplies other muscles as well, that rises from the oculomotor, the trochlea, the abducent, and the hypoglossal. All these are in a straight line. If you can see it exiting from the brain, they are in a straight line, and they supply the voluntary muscles, skeletal muscles of the head and neck. So that is your general somatic efferent. Like that, you should be able to assign some of these functional columns to each nerve. So that is one exercise that you have to master. Now, the nucleus ambiguous. What is the nucleus ambiguous a part of? Special visceral efferent. Right? So these are some of the what you call more important part, the gist of the matter. That is how the medulla differs from the spinal cord. Now we look at the next slide, which are external features of this medulla oblongata. Now look at the external features of the medulla oblongata. Is this the ventral aspect? No, it's written here very well. The dorsal surface of the medulla. Now you can see that there's a posterior median sulcus that passes through the middle, just like in the case of the spinal cord, we have a posterior median sulcus. And on either side, you can see there's some elevation here, and so also here also there's an elevation. So this particular elevation is the fasciculus gracilis, and this one is the nucleus gracilis, or the gracial tubercle. That is where the nucleus gracilis is located. And this is the fasciculus cuneatus and the nucleus cuneatus. Now, from where does this fasciculus gracilis come from? What is it all about? When you looked at the spinal cord, you must have seen that there's a lateral spinothalamic tract, and also in between the two posterior horns of gray matter, there is a white matter tract on funiculus. So that is what is called as the dorsal column. And what is that? How does that differ from the lateral spinothalamic tract? The lateral spinothalamic tract conveys pain temperature, whereas the anterior crude touch and pressure. Where the posterior column, it mediates posterior column sensation, that is vibration and position sense, 2-point discrimination, and so on. So that is your posterior column sensation. And those fibers which pass through the posterior column do not decussate at the segmental level, whereas the lateral spinothalamic tract, it decussates at the same level and goes up a little bit slightly superiorly as it crosses over. But the posterior spinothalamic tract, or the posterior column, it does not cross. It goes directly up to the nucleus gracilis or the nucleus cuneatus, and then from here it crosses over, and that crossing over is what you call as the sensory decussation, or the great sensory decussation. And then the next, after decussating, it becomes what you call as the medial lemniscus. So this is called as the dorsal column medial lemniscal pathway, right? And then finally this medial lemniscus will ascend higher up and then reach the thalamus, ventral posterolateral nucleus of the thalamus. So that is where it ends. So that is the difference between your dorsal column and the lateral spinothalamic tract. Then here you got a nucleus cuneatus and a fasciculus cuneatus, and nucleus gracilis and the and the nucleus cuneatus. Now, what is the difference between these two? The nucleus cuneatus comes from the upper part of the body. So as the fibers come from the lateral aspect, they are added to the sides like this. So the nucleus cuneatus, the fasciculus cuneatus is present only in the upper part of the body, whereas the fasciculus gracilis comes from right below the body. So that is the difference between these two. And then this nucleus cuneatus has also another function, that is, it will also give out small fibers that go through the inferior cerebellar peduncle and then give fibers to the cerebellum, cuneo-cerebellar fibers. So that's also seen in the nucleus cuneatus. So those are the two things that we like to that's seen on this dorsal aspect here. And then, since you don't see the pons here, we don't we cannot make out the actual demarcation here, because unless you know exactly where the pons stops. So here you can see the vagal triangle, the hypoglossal triangle, and the vestibular area. So all these again belong to the medulla, whereas these pontine nuclei that you see here, that is the level of the demarcation between the medulla and the pons, right? Okay, so we'll look at the anterior aspect now. Yeah, this is the anterior aspect, and you can see this big pons which mediates the middle cerebellar peduncle right in front and dominating this particular picture. And then you can see this nucleus, this coming out of the pons, which is your trigeminal nerve. It does not concern us here because it does not belong to the medulla. But as you look here, you can see that this is the abducens nerve, and I told you that the general somatic efferent column, which supplies the skeletal muscle, voluntary skeletal muscle, is in a straight line: oculomotor, trochlear, abducens, and hypoglossal. Now, if you look at the hypoglossal, you can see the nerve roots of the hypoglossal here. On either side of these two elevations and these two elevations, that is the central elevation here and the lateral elevation over here. So this is the rootlets of the hypoglossal nerve. And this is your pyramid, the pyramidal tract. And this is the olive, which is formed due to the olivary nucleus that lies deep to it. Now this pyramidal tract is made up of what? The corticospinal fibers. Where do the corticospinal fibers come from? Oh, you are not gone into the cortex, so maybe I should not talk about the corticospinal fibers here. Anyway, these corticospinal fibers, they come from the motor cortex, descend down through the internal capsule, through the crus cerebri, and then they come here. And then they group together in this region, and this forms an elevation that's known as the pyramidal tract. Then if you see here, it is said, sorry, my printing is not very good there. You can see some area over here. So this is where this corticospinal tract will cross to the opposite side. See, about 75 to 90% of the fibers, they cross to the opposite side at this decussation of the pyramids, so that the left side of your hemisphere controls the right side of your body. So that's what happens here, the crossing over at the decussation of the pyramids. So this is also a part of the medulla oblongata, and we'll see the events that take place in the crossing over of the pyramids. Then just between this olive and what lies behind the olive, which I cannot see here in this diagram, but what lies behind the olive here is the inferior cerebellar peduncle, which connects the medulla to the cerebellum. So the inferior cerebellar peduncle lies behind the olive, and you can see that some fibers, nerves, take origin from between the olive and the inferior cerebellar peduncle. So which are these fibers? So you can see that you got the glossopharyngeal nerve, that's the 9th nerve, the 10th nerve, the 11th nerve, So these take origin from a straight line here between the olive and the inferior cerebellar peduncle, whereas hypoglossal nerve is located slightly more anteriorly, right? And here, between the pons, you can see the vestibulocochlear nerve, see, as well as the facial nerve. So this is 6, 7, 8. So this is your vestibulocochlear nerve, or the nerve, that auditory nerve. So that's what you see here. So these are the external features of your medulla oblongata. Now we'll go to the next slide. Oh, I got a better picture here. You can just take a look at what has been just said and try to reinforce whatever you've made out. See, deliberately I've removed all the the captions here, and only left 9, 10, 11, and the 12th is more anterior, even though here it looks more at the same level, but this is the 12th nerve in an anterior plane, where the 9th, 10th and 11th are in the posterior plane. Now this is a lateral view of the same thing, where you can see the inferior cerebellar peduncle that goes behind here. That's inferior cerebellar peduncle, the olive, and your pyramidal tract. Right? I flip to the next slide. Now this is again those dorsal columns that the gray matter divisions that I talked about when we are talking about in the initial phase. So here you have the substantia gelatinosa, the nucleus proprius, the dorsal nucleus or the Clark's nucleus, then the intermediolateral concerned with the viscera, and these are your motor neurons, the lateral ones innervating the limbs, the medial ones innervating the trunk muscles, and here maybe in the cervical region you have the phrenic nucleus and so on. So that is your anterior and posterior horn and intermediate horn. Now the questions that can usually come when you're talking about the pyramid is, draw a neat diagram, a labeled diagram of the medulla at the level of, it can be decussation of the pyramids, it can be the sensory decussation, or at the level of the olives. So these are the questions that you are mostly asked. So we just look at the different levels. The lowermost part of the medulla, which is called as the closed part of the medulla, is the decussation. You are in the decussation of the pyramids as well as the decussation of the sensory. There's the dorsal column, and beyond that you have the open part of the medulla, where you find the olivary nucleus and vestibulocochlear nucleus. So we'll just see what are the structures that you see in this particular area. So here, what happens to the posterior gray column as it comes to the area, the level of the decussation of the pyramids and becomes the medulla. So here, this substantia gelatinosa, which conveys pain, touch, temperature, and also pain, touch, and temperature, that becomes the spinal nucleus of the trigeminal nerve. As you might remember, the trigeminal nerve is the sensory nerve of the face. So here, the same sensory nerves which you have in the other parts of the body, which brings in pain, touch, temperature, and all that, that is mediated by the trigeminal nerve. So you see, the posterior horn is replaced by the spinal nucleus of the trigeminal and the spinal tract of the trigeminal nerve. So that is what you see here. Then you find the nucleus cuneatus and the nucleus gracilis. So these start appearing just anterior to the fasciculus cuneatus and the fasciculus gracilis. So this is the fasciculus gracilis, the fasciculus cuneatus, and the nucleus start appearing here. That's on the dorsal plan. Here again, the posterior gray column is divided, and this becomes the sensory part becomes the nucleus gracilis and nucleus cuneatus. So these two are sensory. Then the accessory cuneate nucleus, which gives the cuneo-cerebellar tract. The posterior external arcuate fibers, they pass to the inferior cerebellar peduncle to the cerebellum, isn't it? So what is the equivalent in the spinal cord? You have the spinocerebellar fibers. So spinocerebellar fibers, instead of that you have from the cuneate nucleus you have got some fibers that pass to the cerebellum. So spinocerebellar fibers is replaced here by the cuneo-cerebellar fibers. So that's what those are the changes that take part in the posterior gray column. Okay. Now, what happens to anterolateral funiculus, which lies between the spinal tract of the trigeminal and the pyramid? So here it shows the ventral and dorsal spinocerebellar tract. That is what we had before itself. So here, ventral spinocerebellar tract, that's called the anterior spinocerebellar tract. Then you have the posterior spinocerebellar tract. And here you have the lateral spinothalamic tract. So these tracts, which were in the lateral funiculus of the spinal cord, they have been slightly displaced to lie between the spinal nucleus of the trigeminal and the decussation of the pyramids. See? So this has come like that. Then you have the spinotectal, the spino-olivary tracts that go up. It's not marked here, I think. Yeah. Spinotectal tract, that should be somewhere here along with the lateral spinothalamic tract. And what does spinotectal tract do? Where does it connect? It connects the sensory nerves or sensory tract with the superior colliculus of the midbrain. Now, what is its function? If somebody calls you like this, you look behind. So that is the spino-visual reflexes, which are mediated by the spinotectal tract. Then you have the spino-olivary tract and tracts that come down. That's the descending tracts, which are the rubrospinal tract and the vestibulospinal tract. So these you will have to do a homework there and then find out where exactly they're located. So this takes a little bit of memorizing. So what you have to do, ideally, you have to draw this particular section and then stick it on the wall next to your bed so that you can look at it every time and then remember where it is and where these tracks go, because it's not very easy to remember. Of course, I just tried to give some logic into what the connection between the spinal cord as well as the medulla. But even then, because of the displacement of these various tracts and the nuclei, you might have to mug it up. So that's it. So this is at the level of the pyramids. Now we come to the next slide. This is at the level of the sensory decussation. Now the sensory decussation, what happens is, but maybe I should go back one step because maybe you do not understand what the pyramidal tract is like. See, this is the pyramid which you have seen on the ventral aspect of the medulla. Now you can see that the pyramid is crossing over. See, it crosses over like that. Then what happens to this pyramidal tract? It becomes the lateral corticospinal tract. The lateral corticospinal tract. And then, do all the fibers of the pyramidal tract cross over? The answer is no. there's about 75 to 90% of fibers crossover. The rest of it passes in the anterior part known as the anterior corticospinal tract, and they cross at segmental levels. So that is the corticospinal tract. Now, of course, we come to the next slide. So this is a level of the sensory decussation. Now, do all sensations decussate here? No. The spinothalamic tracts, the anterior and lateral spinothalamic tract, they decussate at the same segmental levels or slightly above. So that is where they decussate. But here, it is the posterior columns that decussate at this great sensory decussation in the medulla, because the posterior columns do not decussate at segmental levels. They go straight up in the ipsilateral. That's the ipsilateral means same side posterior column as the fasciculus gracilis and fasciculus cuneatus. And when they reach the medulla, they terminate in the nucleus cuneatus, nucleus gracilis, and nucleus cuneatus. Now, which order neuron is that? See, mostly when we talk about this neuronal chains, we say that the first order neuron is situated in the posterior root ganglion or the dorsal root ganglion, and from there it gives a central process which will go to this spinal cord, and the peripheral process that comes from the periphery and brings sensations from the periphery through your peripheral nerves. So the central process in this case, instead of synapsing in the substantia gelatinosa or the nucleus proprius or the nucleus Clark's nucleus, it just goes straight up to the nucleus gracilis or nucleus cuneatus. From there, the second order neuron will then go to the, it will cross over, the fibers will cross over and then terminate in the thalamus. From the thalamus, the third order neuron will get projected into the sensory cortex. So that is the 3 neuron chain that you get there. So that is where you find that the decussation, so sensation from the left side go to your right cortex and from the right side goes to your left cortex. So this is the sensory decussation. So the rest of it is mostly similar to what we have seen in the pyramidal section of at the level of the pyramid. But the slight differences are efferent fibers pass ventromedially, disconnecting the spinal nucleus of the trigeminal as internal arcuate fibers. So internal arcuate fibers, which is called internal arcuate fibers that cross over, and then they cross the midline and ascend as the medial lemniscus, forming what is called as the dorsal column medial lemniscal pathway. It ascends between the pyramid ventrally and the tectospinal tract dorsally. So that's your dorsal column medial lemniscal pathway. This is an enlarged view. Then the cranial nerve nuclei that you find at the level of the great sensory decussation is. No one can hear me? What happened? They say there's something wrong with audio. You can see me at least. Yeah. I don't know whether it got moved. Yeah, so here we have got the cranial nerve 12, which is the general somatic efferent, which innervates all the muscles of the tongue, except the palatoglossus. That's why it's written not equal to. They say that the audio is not clear. Students' feedback is that the audio is not clear. Now we can't see. Okay, I think I'm audible now. So the cranial nerve nuclei at the level of the sensory decussation, the 12th cranial nerve, which is the general somatic afferent column, along with, if you remember, oculomotor, trochlear and abducen. So these four are general somatic efferent, sorry, I made a mistake there. It should be GSE, okay? It's not GSA, it is GSE, efferent column. I didn't even notice now. Okay, so that supplies all the muscles of the tongue. Please correct it, GSE. Then the 10th cranial nerve, general visceral efferent, which gives the dorsal nucleus of the vagus, the parasympathetic innervation of the heart, the respiratory and alimentary systems, and glands. So that is general visceral efferent column, which is mediated by the vagus nerve. Then you have the nerves of the nucleus of the tractus solitarius. Now the tractus solitarius mediates the sense of taste. Now I have written X, that is 10th cranial nerve, 9th cranial nerve and 7th cranial nerve. So the 9th, 10th and 7th supply the taste fibers to the tongue. So 7th supplies the anterior 2/3 of the tongue, the 9th supplies the posterior 1/3 of the tongue, and the 10th supplies a small part on the epiglottis. So all these have got small contributions from the tractus solitarius. So these are visceral afferents because they take the sensation towards the nucleus of the tractus solitarius. Don't forget to correct this. 12 is general somatic efferent. Now this is the next level that we have to study, which is the level of the olives. So at the level of the olives, we can divide it into the medial zone here. See, there's a medial zone which lies between the hypoglossal nerve as well as hypoglossal nucleus here. So here what do we have? We have the pyramid, then arcuate nuclei. Now what does the arcuate nuclei mean? Now the arcuate nuclei are supposed to be displaced pontine nuclei, which take the fibers, posterior external arcuate fibers, or anterior external arcuate fibers, arcuate fibers to the cerebellum. It is supposed to be displaced pontine nuclei. And then you find the pyramid, and behind the pyramid you find the medial lemniscus, which has come from the dorsal column medial lemniscal pathway, mediating proprioceptive sensations. Then you have the lateral spinothalamic tract, which comes here, along with some more some more tracts that what did I say now? I start from the beginning then. So this is the pyramidal tract. Then you have the medial lemniscus. Then you have the tectospinal tract and the medial longitudinal fasciculus. So tectospinal tract, we already said that it comes from the tectum of the midbrain, superior colliculus towards the spinal cord. And then those tracts will also mediate spino-visual reflexes. So here, when you follow something, you can move your head, isn't it? So that is mediated by the tectospinal tract. The medial longitudinal fasciculus connects the auditory and the visual nuclei. So that is the medial longitudinal fasciculus. So those are the structures that are seen in the medial zone of the section at the level of the olives. To have the anterior external aquaculum. Now, when you look at the floor of the fourth ventricle, you can also see some fibers coming from this arcuate nucleus, which will pass transversely. There it is more obvious. So that is what is called as the stria medullaris, and then that can pass through the inferior cerebellar peduncle to the cerebellum. So again, when you study about the pons and the cortico-pontocerebellar fibers, you will be able to appreciate these fibers from the displaced pontine nuclei. Now, again, the medial zone, corticospinal fibers of the pyramid with the arcuate nucleus. What is this? Repetition? Sorry. Okay. This is the level of the olives, the intermediate zone. Ventrally, you have the principal inferior olivary nucleus and its medial and dorsal accessory olivary nuclei. So here, this is the olivary nucleus that looks like a crumpled bag. See, olivary nucleus, inferior olivary nucleus, and these are the dorsal and medial accessory olivary nuclei that you see on these two sides. Right? The efferents to this olivary nucleus come from the cortex, the red nucleus, and the spinal cord. So, and the efferents go to the cerebellum. So that is what you find. That is the function of this inferior olivary nucleus. Then dorsally you have the dorsal nucleus of the vagus here, the dorsal nucleus of the vagus, and the solitary nucleus on the lateral aspect, nucleus of the tractus solitarius, which you have already looked at in an earlier stage. So that is the intermediate zone at the level of the olives. You have the median zone and the intermediate zone. Then coming to the next one, hypoglossal nucleus, which passes between the medial and intermediate zones. Unfortunately, my previous diagram was more correct. See here you see the hypoglossal nucleus and the hypoglossal nerve that passes between the medial and the intermediate zones. Now at the level of the olives, the lateral zone, principally you have this big green colored structure here, which is the inferior cerebellar peduncle. Then you have the medial and inferior vestibular nuclei. So where's the inferior medial vestibular nuclei? So this is the medial vestibular nuclei, and here you have the lateral vestibular nuclei. So you have the vestibular nuclei at this level. I don't see all the nuclei here, medial and lateral vestibular nuclei. And usually you have got superior and inferior as well, which you cannot see at one single plane maybe. That's why it's not depicted in this particular diagram. So it should be something like a diamond-shaped structure, which you can see in some diagrams. So here you have the vestibular nuclei, the inferior cerebellar peduncle, the posterior cochlear nucleus. So the vestibular cochlear nerve comes and ends here. So you have the posterior cochlear nucleus, the medial and lateral vestibular nuclei. So that's seen in the lateral zone. And the nucleus ambiguous lies deep to the inferior salivatory nucleus. So this is the nucleus ambiguous that you see here. So you find the inferior salivatory nucleus, which should be somewhat more superficial, and then you have the nucleus ambiguous here. So these are the structures that you find at the lateral zone at the level of the olives. Same, but a little bit more enlarged. Then the other structures seen at this level will be the spinal tract of the trigeminal nerve, which lies anteromedial to the inferior cerebellar peduncle. That's depicted in gray here. The anterior spinocerebellar tract, which is seen here, anterior spinocerebellar tract. What happens to the posterior spinocerebellar tract? It's already gone in through the inferior cerebellar peduncle, so you don't see that here, right? Then the spinal lemniscus. So the spinal lemniscus, it consists of, where is spinal lemniscus? It's not very obvious here. The spinal lemniscus consists of the anterior spinothalamic tract, the lateral spinothalamic tract, and the spinotectal tracts. Together, they form the spinal lemniscus. I don't find it in this particular picture. Okay. Then the reticular formation is this dirt-like structure on either side. So this is the reticular formation that you see here. And then the 9th, 10th, and 11th, which run forward through the reticular formation to emerge between the olive and the inferior cerebellar peduncle. So here they should come out through this groove, whereas the hypoglossal nerve you've seen comes out between the pyramid and the olive. So it comes out like this, whereas these 9th, 10th, and 11th will pass through this groove. And yeah. Then blood supply of this medulla oblongata. It's supplied by the vertebral artery, the anterior and posterior spinal arteries, the posterior inferior cerebellar artery, and the basilar artery. So these are the 4 principal arteries that supply the medulla. So there's a picture of this arteries which supply the medulla oblongata, and then you can see that the areas that is supplied by these arteries. See, you have the anterior spinal artery supplying here in the midline, vertebral artery, and the posterior inferior cerebellar artery, mainly supplying this structure. What was this? The inferior cerebellar peduncle as well as the trigeminal nucleus, isn't it? So that's what you see there. So let us trace these arteries. There is a vertebral artery that comes in through the foramen magnum, and you have the posterior inferior cerebellar artery coming as a branch from that, and then these 2 vertebral arteries uniting to form the basilar artery and passing upwards. You can see your medulla in the background, and there's the anterior spinal artery passing through the midline. Now we can see that one part of this particular diagram has been blackened out. Now, why is that blackened out? Now what has happened here is this posterior inferior cerebellar artery has been thrombosed. So this area has become infarcted. That is, there is no blood supply here. So this area is dead. So here you find this is what is called as the lateral medullary syndrome. So what are the structures that may have been involved in this, and what are the consequences? So you can see here, this inferior cerebellar peduncle is blackened out, spinal tract of the trigeminal nerve is blackened out, inferior vestibular nucleus is also blackened out, maybe the cochlear nucleus is also blackened out here. So what are the consequences of this blockage and then infarction of these structures? So we'll see it in the next slide. See, the lateral part of the medulla is supplied by the posterior inferior cerebellar artery. So what does it cause? Dysphagia and dysarthria because of ipsilateral palatal and laryngeal muscle paralysis. The nucleus ambiguous is paralyzed. So you can go back a little bit, I think. See, the vagal nucleus is also gone. The dorsal nucleus of the vagus may also be affected. So you can see the vagus going out like that. That's also blackened out. So you find palatal paralysis. So what happens if you have palatal paralysis? You have nasal regurgitation, isn't it? When you drink something, it will come out through your nose. And laryngeal muscles also, your voice may be changed because the laryngeal muscles are affected. Then what else? Your palate, when you say ah, the palate will move to the opposite side because the muscles on this side will not be pulled, so the palate will go to the opposite side. So that is what happens in the case of lateral medullary syndrome. Then analgesia and thermoanesthesia, the ipsilateral nucleus and spinal tract of the trigeminal nerve. Let's see what happens. See, we said about the spinal tract and ipsilateral nucleus of the trigeminal nerve. So when that is gone, you find that one side of your face, you don't feel ipsilateral analgesia and thermoanesthesia because of the infarction of the ipsilateral nucleus and spinal tract of the trigeminal nerve. Then vertigo, nausea, vomiting, and nystagmus because of the lack of balance and the vestibular nucleus, which is affected. Then ipsilateral Horner syndrome, because the sympathetic fibers that descend from the higher centers have to pass through this area. So you get Horner syndrome. Ipsilateral cerebellar signs because of the inferior cerebellar peduncle being affected. Contralateral loss of pain, touch, and pain and temperature. That is, the spinal lemniscus is also affected. So you find ipsilateral loss of pain and temperature in the area of the face, not the entire body. So that's what happens in case you have got a lateral medullary syndrome or Wallenberg syndrome because of infarction of the posterior inferior cerebellar artery. Now we come to the next one. In this case, you see that this area here is blackened out. See, this is the area supplied by the vertebral artery. It is blackened out. And you can see that the pyramidal tract is not to be seen. The medial lemniscus is not to be seen. The tectospinal tract is affected, as well as the arcuate nucleus is affected. And also the hypoglossal nerve is also affected. So let's see the consequences of this particular problem. So this is what's called as the medial medullary syndrome. Because the medial part of the medulla is supplied by the vertebral artery. So something goes wrong with your vertebral artery, you get this particular condition. You get contralateral hemiparesis because there is one side of your body is paralyzed because your pyramidal tract is gone. Then contralateral dorsal column sensations are gone. So you have problems with 2-point discrimination, position and vibration sense and all that. So the medial lemnis is gone, you get contralateral dorsal column sensations gone. So if you put a tuning fork on that side, on the opposite side, you find that this person cannot appreciate the vibrations of the tuning fork, nor can he appreciate if you put 2-point discrimination, that is, you put a divider at a distance and then try to poke him and say, can you feel 2 points or you can feel only 1 point? That's also gone. So your dorsal column sensations are gone. Then ipsilateral paralysis of the tongue. You tell him to protrude his tongue. What happens is, will the tongue go to the same side or the opposite side as the paralysis? It goes to the same side because the other side is not paralyzed. You find that side the tongue pushes forward, so it goes to the paralyzed side. So that is the ipsilateral paralysis of the hypoglossal nerve. So this is the gist of your medulla oblongata, right? It needs a little bit of imagination, and also when you talk about the different nuclei and all that, please note that when you have the different nuclei and know which nuclei are there in the medulla, that is the 9th, 10th, 11th and 12th, you will be able to and and you try to correlate it with the functional columns, I think you should be able to make some sense out of it. Any questions? Yeah.
Ask them to
Yeah.
unmute and ask them.
Yeah. So altogether, I don't think you can ask. You can ask one by one if you have any doubts. Unmute and ask. And they know how to unmute and ask. They're very smart guys.
Smart ones.
Yeah. So what you have to do is sum up all the nuclei that you can find there at the different levels, as well as the tracks that go up and down. So that is your exercise when you start studying about the medulla. Okay, I think that's it. All the best. Bye-bye.